In this lesson, we are going to learn about geometric sequences. If you take a look, this is kind of just what we did with arithmetic sequences yesterday, but now we're going to do it with multiplying instead of adding. So a geometric sequence is a sequence in which each term after the first is found by multiplying the previous term by a constant. The common ratio instead of the common difference. Common difference was for arithmetic, common ratio is for multiplication. The ratio of the successive terms in a geometric sequence, what you multiply by to get to the next term. That's what it is. So you'll notice in blue here I have a geometric sequence. Hopefully you can see that from one term to the next we are multiplying by -3. And so that would be our common ratio for this problem. The one thing I want to point out is that sometimes you'll notice that our numbers are going to get smaller, and we're not ever going to be dividing. If we were, let's say, dividing by 3, we would call that multiplying by 1/3. So if you're multiplying by a fraction, you'll see your numbers get smaller. We would never call that division, though, even though that might be what you think of it as. So for this one, we're going to look at one that is going down. So we're asking ourselves, what's happening from one term to the next? So what I would do is I would say, okay, it looks to me like it's divided by 3, especially right here, you can see that, right? And so when we think of it as division, we actually have to call it multiplication, though. So dividing by 3 is the same as timesing by 1/3. So we're going to be timesing by 1/3. That would be my common ratio. So that's my R value, which is going to come up in our equation. If you wanted to figure out the sequence, if I just divide this by 3, I realize my next term is 4. Or if I times it by 1/3. So however you get to this answer is fine, but when you're asked for your common ratio, you'd have to list the fraction because you list what you would multiply by, not what you divide by. Number 2, you'll notice that my signs are changing, everyone, which tells me that I'm multiplying by a negative, and hopefully you can see we're timesing by -5 here. So when I take 375 times a -5, I would get -1875. So there's how I find those next terms. Our formula then, we have explicit and recursive just like with arithmetic. My explicit formula, nothing really new here. an is still the value of the nth term. a1 is still my first term. The difference here is that I have a common ratio. That's my common ratio instead of my common difference. Oops, let's spell right there, that's an n. Common ratio. And then you'll see that it's an exponent up here. We have an n, it's raised to the n-1 power. Hopefully you can see how this kind of relates to our last chapter on logs, because if we leave that n as a variable, we're going to have to use logs to solve this because we can't have a variable in our exponent. So there's the formula for explicit. Recursive then is r, our common ratio, times a to the n-1, so times the previous term, which makes sense. If I'm timesing by 2 to get from one term to the next, so let's say we start with 2, 4, 8, 16, 32. These are all timesing by 2. To get to the next term, I take my common ratio, which in this case would be 2, right? I'm timesing by 2. From 1 to the next, I take the previous term times 2. Previous term times 2. Previous term times 2. That's how I get to the next term. So that's where recursive comes in. In number 3, it says write the first 5 terms of a geometric sequence for which -3 is the first term. So that's my a1. So I'd say a1 is -3, and my common ratio is -2. So I start with -3 here, and then I'm just going to keep timesing by -2 to get to one term to the next. So times by -2 I get 6, times by -2, times by -2, times by -2. So that's how I could make a list of those, which those hopefully should be kind of simple for you, as long as you're not making a simple multiplication error. Here now it says use this sequence and write the explicit formula. So my explicit formula for this sequence, I'm just going to look at it first, and it looks like what's happening is I am taking and I'm going to go ahead and look and say, okay, what's happening from one to the next? Well, this is my a1, and it looks like I'm timesing by 2, right? Everywhere as I go through. So I would say my a1 is 5, and my common ratio is 2. I don't know what term they're looking for. When you're doing an explicit formula, you leave it in terms of n. And that's as far as we can go. Yesterday with arithmetic, we actually could simplify this more. And some people might be thinking that they could write this as an equals 10 to the n-1. But remember, you can't do multiplication before you do the exponent. So we have to leave it the way it is, and that would be improper to write it that way. And then it says use the formula to find the 20th term, is how we would say that. So we'd say the 20th term equals 5 times 2 to the 20 minus 1. So as I go through and simplify this, I would use my calculator and I would actually take 2 to the 19th power and then times that by 5. And you can see how these numbers grow pretty quickly because we're timesing by 2. That would be considered exponential growth almost, wouldn't it? And so when I get that, I get 2,621,440. And that would take me a while to get to that if I was actually doing the 20th term. Hopefully that makes sense to you. We're going to do one more like that. This one, you can see that the numbers are going down, and I know my A1 is here, so I'm going to plug that in for A1. It's 2048. And this time they're actually asking for the recursive formula. So first I have to figure out what I'm multiplying by to move from one term to the next. I'm looking at this thinking it looks like I'm dividing by 4, so that would be timesing by 1/4. And since my signs are changing from positive to negative, I'm timesing by -1/4. Now to check that, if I'm not sure I'm doing that right, I would take 2048 times -1/4, and I should get -512. Times that by -1/4, and I should get 128. Times that by -1/4, I should get -32. And that confirms that my ratio is correct with what I thought it was of -1/4. So now to do my recursive formula, I say the nth term equals, my common ratio I just decided was -1/4, and then I'll take that times the previous term. And that's all I do for the recursive formula. So when it says find a to the 7th, I'm going to see that I have 1, 2, 3, 4 terms here. So I know my 4th term is -32. So to find my 5th term, I would take -1/4 times that previous term, so times -32, and I would say that my 5th term then is 8. And then I keep going until I hit my 7th term. So I'd say, okay, to find my 6th term, I would take my common ratio times my previous term. So my 6th term is -2. Now to find my 7th term, which is what we're looking for, I take -1/4 times my 6th term. So my 7th term is 1/2. And that's what they were asking for. Now I will agree with you when you say this seems really stupid to write all this work. I agree. I think you guys could come up with the 7th term just by listing 7 spots and putting them in, and that would seem easier. But we are required to demonstrate the recursive method. So I'm going to require that you show that in the way that I just showed it here. I know it doesn't make a lot of sense to you, but I have seen questions on your MCA and ACT that look like this, and you have to be able to write it in this way. So I'm hoping that will help you if you run something like that. If not, and you get one where you can just list them out, then you'll be able to do that, because that's something that's pretty easy for you to do. So I want to work on something that's not as easy. Our last couple then, we're going to do number 6. It says find the 7th term. So when they say find the 7th term, we realize that's our n value, right? Of a geometric sequence for which A3 is 96 and the common ratio is 2. Now when they're giving us A3, they're giving us a value. So A3 is 96, so we know n would be 3 just for this case, right? So we're going to plug in what we know to find A1, because that's what we're missing here. We were not given the first term. We don't know this. So we're going to plug in what we know. We know the 3rd term, so just to pause for a second, I'm not going to find the 7th term until I find A1. That's what's missing. I need A1. I need my first term. So my first job is to find that first term. So I'm going to use what they give me, this 3rd term, and plug that into my formula. So I'll say the 3rd term is 96. I don't know A1, but I know that my common ratio is 2, and I know that it was my 3rd term I just found. So I'd say to the 3 minus 1. So I'd have 96 equals A1 times, well, 3 minus 1 is 2, 2 squared would be 4. So to find A1, I just have to divide both sides by 4. So I would see that my first term is 24. Now that I know my first term, so now that I know A1, my first term, I can plug this into this formula and find my 7th term. So I'm going to say the 7th term is the first term times 2 to the 7 minus 1. So as I simplify this, remember you do your exponents before your multiplication, so this would be 2 to the 6th. When I take 2 to the 6th and then times 24, I find my 7th term to be 1,536. So this was a 2-step problem. They wanted me to find the 7th term, but in order to do that I needed to know my first term. So I used the information they gave me right here to find my first term, and then I could find my 7th term. The last one we're going to do, it says how many terms are in this sequence. So they give us the sequence of 3, 6, 12, 24. Hopefully you see that it looks like we're timesing by 2 here. So I'm going to say my R is 2, my A1 is 3. What else do I know? I know this is some term. I don't know what term it is, so I'm going to say this is my nth term. That's the value of my nth term. I don't know what n equals, that's what I'm looking for, but this is the value that's in there. So when I plug that into my formula, I would say the nth term, so the value of the nth term, 98,304, equals A1, my first term, times my common difference to the n minus 1. This is where we use our log information from chapter 10. Before I can put it in log form though, I'm going to divide both sides by 3, so this is gone. And I would have 32,768 equals 2 to the n minus 1. So now, if I can find a common base, I could use common bases. I don't happen to know off the top of my head if 2 to some power equals 32,768. So I'm going to choose to take a log to both sides. So I'm going to go log, and then I'm going to power rule this, right? So I'd have, let me move down here for you, the log of 32,768 equals n minus 1 times the log of 2. So to get my log by itself, I'm going to divide both sides by log 2. And let me punch this in my calculator now. I would have log of 32,768 divided by the log of 2, and I get approximately 15. Actually, I shouldn't even say approximately, it is 15. I didn't have to round, it gave me exactly 15. So I have 15 equals n minus 1. So then I go ahead and add 1 to both sides. And my n is 16. So what that's saying is the number 32,768, or I'm sorry, the number 98,304 is my 16th term. That's what we just found. So I was working to find that n value. Hopefully that makes sense to you. You're going to have problems just like this in your Excel math. You will have, for your homework tomorrow in class, you'll do objectives 120 to 122. And then that 11.1 worksheet you did with arithmetic, the back side had an 11.2. And that just deals with the recursive things. Make sure you let me know if you have any questions on that.